So today, let's talk about some bad notations in math. However, these right here, they are not necessarily bad. It's just that these notations are also used in different contexts. So have a look. For the first one, it's like the one that we did earlier. I'm going to compare the degree notation versus the exponent notation. In particular, the zero exponent notation. Earlier, I put down 0 with a little circle here. Imagine if you just see this somewhere on the board. Imagine if you see this as a painting, like in my room or something. How are you going to interpret that? Well, I can say this right here is equal to 0 because I'm taking this as 0 degree, and the result for that is the same as 0 radian. Then that's totally legit. And I really know, when you type the degree symbol, it's much more clear. It's a degree symbol, it's a perfect circle, but when you write, you really write it like this, right? On the other hand though, if you have 0 to the 0 exponent, oh my goodness, this right here, is it 1? Is it 0? Is it undefined? Well, I'll tell you, this right here has no agreement. And that's all I'm going to say. And in fact, I encountered this when I was teaching pre-calculus on the other day because I was doing 5 with a little circle plus 7 with a little circle, and then I found myself that I had to write 12 with a little circle because these right here are degrees. So to me, it's kind of bothering me. On the other hand though, just real quick, if I have 5 to the 0 plus 7 to the 0, this right here, I can also write it as 2. Why? Because when we have the 0 exponent, any non-zero number to the 0 exponent is just equal to 1. So really we're just doing 1 plus 1, which is equal to 2. Degree versus the 0 exponent notation. In fact, the next one is even worse. And I am talking about if you have a point, and of course we're talking about the x comma y notation, versus the interval notation. So just a quick example. Let's say if we have 1 comma 4. If I just put this down on the board, well, without any context, you can interpret this as a point, meaning the x value is 1 and then the y value is 4. And of course, you can just go ahead and plug them. X is right here is 1, and I say 1, 2, 3, 4 is 4 right here. So you have our point. Everybody happy, right? But if you have 1 comma 4, if this is an interval notation, what this means is that we have an interval going from 1 to 4. So you can look at number line. Here is the number 1. Here is the number 4. Parentheses means that we are not including the n values. So open circles here, likewise here. And we take all the numbers in between. And if you are talking about the interval for the x values, we can denote that this is all the x's in between of 1 and 4, not including 1, not including 4. And of course, we can also write it as x in between of 1 and 4, like that. So 1 comma 4, 1 comma 4. This right here caused a lot of confusions once we started to use the interval notation along with the point. Especially you have to do some like pre-calculus, graphing questions when you're talking about the domain versus the range versus the coordinates of the min-max values. So yeah, and of course there are other interval notations as well. Sometimes you may have a bracket 1 comma 4. This is much more clear that it's an interval notation because the 1 is included, meaning you get 1 here, 4 here, close circle, open circle, and then take everything in between. But the moment you have something like this, when the endpoints are not included, it looks well, it looks exactly the same as a point. Now, I have one more for you guys. Now for the next one, I think it's everybody most disliked math notation. I'm talking about the -1 notation. Either you interpret that as a reciprocal or the inverse function. So let's talk about this first. Suppose I have a number 5 raised to a -1 power. This means 1 over 5. Just a reciprocal 5. And if we have a variable, that's x, raised to a -1, this right here is just 1 over x. no problems on this. However, if you have a function, that's f, and then if you put -1 right here, this is no longer the same as 1 over f, because f is a function. I know f is a letter, very similar to just like x is a letter, but when we say f, we are usually trying to say a function, just like we're saying f of x is equal to x cubed. It's a function. And in fact, if f of x is equal to x cubed, then I will tell you the f inverse, you have to think about what operation can help you get rid of the cube. In fact, that's the cube root of x. So as you can see, when we have inverse functions, it's just not simply doing the reciprocal. And another standard notation is that if you have any trig functions, let's say sine, if you put -1 right here and x, this is also not 1 over sine x, because this right here is a function and then with a -1. It means the inverse function. A better notation for the inverse sine is we write it as arc sine of x, which to many people, they do prefer this over that. Okay, but now, check this out. As I said, if we have a function with a -1, it's not a 1 over. But if I do this, writing sine right here, and then if I put the -1 like this, this really means 1 over sine x. And now you might be wondering, what's the difference though? I will tell you, it's the position of the notation. Notice that the -1 is after the parentheses on the outside like this, and the -1 is right here. So it's the position of the function. So yeah, you just have to be really, really careful on how we write it. Right here, I will just make a note for you guys that sine with a -1x right here, this it's not the same as parentheses sine x and then -1. I also know what you are thinking. What if we don't have -1? I am going to tell you guys, okay? But if today, besides a -1 notation, if we have, let's say, sine with a little 2 right here of x, this compared to sine x and then the 2 on the outside, they are the same. This is the same. This is not. So this kind of like the notation rule only works when we have a just a non-1 number usually. Don't ask me about -2, that's even more bizarre, so don't ask me about -2. When we have -1, definitely don't do it. When we have a positive whole number, let's say 3 or 17, you can do that. Yeah, let me know what you think, and if you have any other bad notations, feel free to let me know too. That's it.